Welcome to another video of RoboCNC. I'm Marcel. Today the first video in the RoboCNC Plasma build. Let's go into the shop. So let's first start with what is plasma. Plasma is one of the four fundamental states of matter. Solid, liquid, gaseous, and you have plasma. So take for instance this ice cube. The ice cube is solid. If I put it on top of this fire, a lot of energy will go into the ice cube, and from solid it will turn liquid. If I were to heat it even more, it turns gaseous, a water vapor. If I would be able to heat this water even more to around 11,700 degrees Celsius, it would break up in different component gases. It would ionize, become conductive, and this highly energized gaseous form is called plasma. So a plasma cutter consists of an inverter with a lot of electronics inside to generate the power to create plasma. Typically in a plasma machine, gases like nitrogen or compressed air are used. In this case, compressed air is fed through a connector on the back of the machine throughout the hose, where in the tip of the torch it becomes ionized to create plasma. So now we know what plasma is, we know what machine can create the plasma, and we know what we can do with the plasma. And if you look closely to my skill level while hand cutting, you also know why I want a CNC machine, a computer controlled plasma cutter. So that's what we're gonna build. So there are a lot of plasma inverters on the market. A lot of them are a lot cheaper than this one, come from overseas and might work just fine for you. I went with this machine, the Hypertherm Powermax 45 XP. At the time it was the newest model. Now there are already newer models, but well, and I'm ready to tell you why I chose this machine for the CNC setup. So let's zoom in the Hypertherm XP and see what it's capable of. So here we see the Hypertherm Powermax 45 XP in a bit more detail. I went with the 45, and the 45 is the 45 amp version, so it has 45 amps of power, output power, to cut through material. With this 45 amps you can cut 16 millimeters or 5/8 thick mild steel with a speed of 500 millimeters per minute, which is 20 inches per minute, and that's pretty much enough for the things I'm planning to do. If you of course want to build tractors or really heavy industrial stuff, you might want to go up to the 65 or the 85 amps, but the downside of that is that you probably cannot take it up to your friend's house and help him, because you will really need heavy power output, so that will only work in your workshop probably. So when you want to do slow cutting, it can cut up to 29 millimeters, 1 inch and an eighth. So that's with 125 millimeters per minute or 5 inches per minute. So if you go slow, you can cut really thick materials. Well, at least Hypertherm tells us. On the right side you see there are a couple of different torches. I have the upper one, which is a really nice ergonomic one for hand cutting, but we will see this bottom one, the machine torch, is much more suitable for CNC purposes. Well, one other last thing it has, when you choose to, has a CNC interface, and a CNC interface, the CPC port, is really something convenient if you're gonna build a CNC machine. So that's why I went with these machines. So here on the back, below this cap, we can see the CPC port. This CPC port is what's gonna do the communication from the CNC controller to the plasma cutter. Because when mounted on a CNC machine, I'm of course not going to push this button and unlock it and do stuff like that. So I want this machine to be controlled by the CNC controller. So as I just showed you, there are different torches. This is the hand torch, which is really ergonomic, but you have to push the button, and the shape of this torch is far from ideal to put on a CNC controlled plasma cutter. So what do we have here? Here we have the machine torch. As you can see from close up, it's quite big. So if you're building a really small machine, you might want to use the robotic torch, which is the mini version of this. But well, my machine is going to be quite big, or for my purposes quite big. So I'm gonna go with the full size. It is quite a big unit. There is still the lock on there, and there's no trigger again. So that's why I told you, you want the CPC port on the back of this machine to control the on-off of the plasma and stuff like that. So first of all, we need to control this. This needs to go up and down in the CNC machine, and there is like a rack and pinion system already on the torch, but I'm not going to use that, and for the purpose it's even quite irritating that it's there. So I'm going to check if I can take this off. So that was an easy fix. The rack of the rack and pinion system is off, since I'm not going to use that. It's now a great cylindrical shape to use a clamp on the CNC machine Z-axis. Remember, the Z-axis is going to be the up and down motion. So it's going to go down to find the material, go up a little bit and start cutting. I could use a really simple clamping mechanism, like a bracket, like the ones used to put hydraulic piping on the wall. Very easy fix. But there's a little problem. If the machine runs into material, which we will see later, we would crash and something could break, or it shifts the material. So what I really want is a detection system to detect when I crash into something and then pause the machine. Again, beautiful stuff to be found on the market. Boss Machines has some beautiful brackets, and I've seen really amazing ideas. But then I went on Amazon and I found this for a ridiculously low price. This already is kind of a Z-axis. If you put a rod in here and the rod goes up and down, you can put it on an angle and all kinds of goodies. I'm going to take this off. I'm not going to use it, but there are some cool tricks inside this thing. Links to the products I use are down in the description box below. Some of them are just links to the product to inform you, some are links to the stuff I use, and some, like this one, is an affiliate link. If you click on this link to Amazon and you buy something, I get a small percentage, and well, you help the channel growing. Anyway, this thing is now a cylindrical piece that could hold the torch like this. Now if the machine crashes, we crash into something, we get a little bit of motion like this. As you can see, there are 3 springs and these 2 parts are not firmly attached, so we have some spring tension. If we combine that with some sensors, we can now put the machine in pause when we crash into something. So the material will not shift, hopefully, and nothing will break. Let's take you in a bit closer on this anti-coalition system. So it's clamped on the torch, and basically this bottom plate is going to be attached to the CNC machine. This is going to be stationary. So this is on the CNC machine, the torch crashes and you see there becomes a gap in the top and the bottom plate. Due to these spring tensioners, there are 3 on this circumference, there is the ability to have this space. There are 3 other holes, this one, and this one, to place an inductive sensor in. I placed one in there just for display purpose. So this is an inductive sensor that senses if this material is close or not. So now it is close, and when we have a crash like this, it will sense that the material is not in front of it anymore, and that we can put into the CNC controller to put a pause or an emergency stop, for instance. So since the anti-coalition system is not supplied with sensors, you have to go online and find your own sensors. But if you Google inductive sensors M12, you will see that there are a really lot of options. I've done it before, and I'm taking you through the steps I took to select these sensors, but no promises. I mean, the machine is not running, so I could still be wrong. Anyway, the sensors I chose are these ones. Specifically, I selected the PSC 1202-NP, which is a NPN sensor with a normally open and a normally closed contact. We will dive into that a bit deeper later on. It has a really small distance of sensing. So typically at 1 millimeter gap it will detect. So if you would, for instance, take this one, the crash would be detected quite late, so that's why we went with a really small one. It has a shielded cable, which is nice because we're gonna do plasma cutting, which probably is going to give us quite a lot of frequencies in the air. Plasma cutting also involves water, so you see this nice connection area is IP67, so it's watertight. It has a nice LED indicator to show us that we are crashing the machine. It has a flat bottom, so I choose this one, flat bottom, so the sensing is for flush mounted sensors, so only on the bottom, and not like this one also on the sides. So this would be much better for like home switches and stuff like that, and the one we chose is much better for the detection of the crash because it's flush mounted. It is not standard M12, it's M12 by 1 millimeter, which is metric fine, and that's exactly what we need. It works in a range of 12 to 30 volts, so if I go 12 volt in the system or 24 volt, which is more likely, both cases it would work. And I think that's it to tell about this. So now, why did we go NPN with a normally open and a normally closed contact? Okay, I will draw the basic schematic of an NPN sensor. So this is NPN. I'm not going to do the PNP, but I'm just showing you why I use NPN. So basically it has a positive lead, it has a negative lead, it has in my case a normally open contact, and it has a normally closed contact. And basically inside here we are connected to the ground. So if we now have a look at a typical CNC controller, it also has a positive lead. It has a negative lead, and it has a lead for the signal. Now, the positive lead is connected to the positive lead of the sensor. The negative lead is connected to the negative lead of the sensor. So now the sensor has internal power for its internal components, the electronics inside there and the LED and stuff like that. So the sensor can now work. So now it is the question, do we connect the normally open or the normally closed contact to the signal? So let's first start with not connecting anything. In a typical CNC controller, and again this can vary between the different CNC controllers, so just check your manual, but in a typical one you would find like an internal resistor R that is connected between the positive lead and the signal wire. So if you do not connect this signal wire, this resistor will basically leak electrons and make this signal wire positive, or as we call high. So if now high would mean that we have an error or we have a crash. So positive is crash. So then the CNC controller can emergency stop the machine or do a pause or whatever. Now that means that having a negative signal or low would mean everything is okay. Keep cutting metal, keep doing what you're made to do. So this sensor now needs to say, signal, you must be low when everything is okay. So this tells me I need to use the normally open contact. Why the normally open contact? Because the signal, the sensor will have this contact open when it is doing nothing, when it's in the box, when it's in a plastic bag, when it's not powered. It does nothing. But in our case, it is sensing that there is no crash, because the flush mounted sensor will detect the bottom plate. So when it is detecting, this basically becomes closed. And if this is closed, we see that the negative is now connected to the signal. So the signal is low, it's negative, and negative is positive. So there's no crash. Now, if there is a crash, the sensor is not closed anymore, it goes back open. So this will not be negative here, but this resistor will pull it back up to high. So then the system says here's a crash. We need to stop or pause the machine. Why do I do it like this? Because I could use the normally closed sensor also. That it's not a problem, but the fact is that if this cable breaks, what will happen? This side might be okay, there's no crash, so this is negative. But this side now doesn't know that it's negative, so it becomes positive via the resistor. And again, the machine says crash. So there is no crash, but it's a safe assumption if the cable breaks. So I would go NPN and go with normally open. Is this the best for your machine? Is this what you need to do? Well, it depends on your controller and it depends on what you want. But well, let's now first check what my controller tells me to do. So I'm going to use my Plasma CNC. I'm going to use the hardware and the software of my Plasma CNC. I'm going to talk a lot about this in later episodes, but it already is ready for anti-collision systems. Let me read. It uses an inductive sensor, which we talked about. It is possible to use the normally open or the normally closed contact, with which basically tells you that you can switch between a pull-up resistor and a pull-down resistor, and with an NPN. So that's correct. And now the most common solution is to use 2 or 3 NPN sensors with the normally closed contacts. Now that's interesting. I am planning to use the normally open contact. So what is up here? Use normally closed contacts in parallel, and I was going to use normally open contacts in series. So on this side we have the negative. When there is no crash, they are all closed. So then there's negative here. If one of them opens up, so this opens up, this becomes positive via the pull-up resistor. This is interesting. I do well, I think I'm right. Anyway, I know you guys are going to know if I'm right or wrong, so I will find out, just like any other viewer of this video, that below is the comment section and you will absolutely read where my mistake is, or well, I think I'm right. Anyway, before we're gonna crash the machine, we are going to test this this system. So anyway, make sure to check out the next videos in this series and you will find out if I'm going to use the normally closed or, as I suspect, the normally open. Okay, it's a bit of a cable mess right now, but as you can see, I placed the 3 sensors on there and connected them to power. So this is not, absolutely not proving anything about the normally open, normally closed discussion we did earlier. So we will finish that up later, but at least you can see the LEDs now indicate that there is no crash. And so if a crash occurs, we will see this LED dies out. This LED also dies out, and maybe this one does not. You see, if I do it further, this one will also die out. So by putting them all three in series, or indeed if they are normally closed, putting them parallel, you can make sure that whatever direction of crash may occur, it will detect. So this was the first video in the plasma build. I'm going to try and build a plasma CNC, and just like a router, eventually it will work out, but maybe just with the router the second version will be better than the first one. But you guys can help. Leave your comments in the description box below. Let me know what you think. If you have any comments or suggestions, we can do this together. And well, I hope you enjoyed looking at the video. This was not much CNC machining, but in the next video we will start on working with the Z-axis, so the part that will be controlling the up and down movement of this plasma torch. Thanks for watching, and hope to see you in the next video.